Welcome to this exciting episode of Math 20-1, where I am going to show you how to add and subtract rational expressions that have binomial and trinomial denominators. My name is Mr. Kennedy, and I am a high school math teacher with currently 7 years experience at the wonderful H.J. Cody High School. You may remember me as the person who walks around crazy at night and does weird things in his sleep, or maybe the person who ate 100 chicken wings for supper. Either way, you'll definitely remember me in this video. I hope you guys know that I watched a YouTube video on how to make my YouTube videos more engaging for you. And they said to always start off by telling you what you're going to do. Yeah. And then introduce myself and make myself sound credible. Yeah, I sound pretty credible, so I'm a teacher with experience. Plus, give them a fact about me so you remember who I am. Chicken wing guy. Yeah. All right, so today what we're going to do is we're going to learn some binomial, trinomial denominators. We're going to add and subtract them. We're going to skip a couple slides that normally we would do in an effort to try to keep this video shorter and sweeter for you. Yeah, YouTube tip number 5, short and sweet. There's just some factoring review. We've done lots of factoring. We don't need to stress factoring review. What we're going to get into is adding and subtracting some fractions. Okay, so let's try to simplify this equation. The first step you should always do is factor, right? Always factoring, always factoring, always factoring to start every single question. When you can't factor, you want to put brackets around any binomials you have so that you remember their package deal. All right, the second thing that you want to do is always state your non-permissible values. Those are things that cause you to divide by 0. In this case, n cannot equal -4. It also cannot equal +5. Either one of those would cause you to divide by 0, and dividing by 0 is bad, at least according to every mathematician who's ever spoken. Third thing, now we want to try to simplify this. Let's just remind ourselves what simplifying something means. It means we want to take these two fractions, we want to rewrite them as one fraction, and then we want to reduce that fraction as much as possible. To be able to write two things as one, when you're adding the fractions, we needed something called a common denominator. We get common denominators by taking the binomial over here and saying, well, this fraction also needs that binomial. And the way we give it that binomial is by multiplying. So this time, in this lesson, we're going to be multiplying by entire binomials to get that common denominator. And we also learned that what you do to the bottom, you do to the top. Unless you're talking about a pizza, because you don't want to put cheese and sauce on the bottom of the pizza, just the top of the pizza, or else it's not going to cook well. Unless putting cheese on the bottom of the pizza would make it better. Oh. Fractions, top and bottom. You want to do the n minus 5. If you look at the second fraction, it's missing this n plus 4. So that means you need to multiply the bottom by n plus 4. And what you do to the bottom, you do to the top. Like that. This gives us 4n times n minus 5 divided by n minus 5 n plus 4 plus 3n times n plus 4 divided by n minus 5 n plus 4. And you'll see that we now have that common denominator. The denominator is n minus 5, n plus 4. We're almost there. If we want to be able to combine these to become one fraction, when we add and subtract, we can't add and subtract unless there's like terms. So we need to take our monomials and multiply them into the top. That will allow us to now write everything as one big fraction. So I now have 4n squared minus 20n, and then plus 3n squared plus 12n. And now it's one fraction. When you become one fraction, the denominators just become 1. So it's n minus 5, n plus 4. I don't write it twice. I'm not multiplying the denominators. I'm just putting them into one whole fraction. Cool. Now that you have one whole fraction, you're almost done. All you have to do is collect like terms on the top. Like terms with these n squares right here. So I have a 4n squared and a 3n squared would combine to be 7n squared. And the negative 20n plus 12n is minus 8n. Divided by n minus 5, n plus 4. You know you are done simplifying a question when you cannot factor the top. If I look at this question, I can factor that top. I could take an n out of it. That would leave me with 7n minus 8. Now I'm done factoring. So the next thing I look for is, can I simplify this at all? Remember, when we're simplifying, especially with binomials, the only way you could simplify is if you canceled out an entire binomial, right? That n minus 5 is attached together. So because I can't simplify an entire binomial with anything, now I'm done. I'm done because I can't factor anymore, and I'm done simplifying or canceling things out. That is adding and subtracting when the binomials are in the denominator. Wicked. Let's try this one. So if we look at this question, we want to simplify it. That means we want to make it one fraction. The first step to every single question is always to factor. So when you look at this question, I actually can factor. That x squared minus 36 is a difference of squares, meaning I can square root it to become x minus 6, and then the conjugate x plus 6. The second one I also can factor. So I'm going to take a negative, and I'm going to greatest common factor in x out. So I have 6 minus x, like that. Now, something interesting happens with this question. And that interesting thing is that when you look at the denominators, actually, sorry, before I get into this, we should see our non-permissible values. My non-permissible values are x cannot equal positive or negative 6. They also cannot equal 0. Okay, perfect. When you look at these denominators, you'll notice that two of the binomials are very similar, right? I have x minus 6 and 6 minus x. Those are opposites, right? The first one has a positive x. The second one has a negative x. First one has a negative 6. Second one has a positive 6. So if I could somehow change the symbols of that binomial, then they actually would be the exact same. And the way we change the symbols is by factoring out a negative 1. If you take a negative 1 and you put it out front, it will change the symbols on the inside. And now those two binomials are the same. And the reason that's good for us is now it's one less thing I have to worry about when I'm getting my common denominator, because it's already common in both fractions. Cool. The next best thing about what we just did is we learned a long time ago in Math 9, when you have a negative like this, it can float out to the top or it can float out front, which means instead of making this a subtraction question, I can float it out front to make it a positive question. And now I have 1 over x minus 6, x plus 6, plus 1 over x, x minus 6. And by doing that little bit of a trick, taking that negative 1 out and then floating it out front, I now have an addition problem, which is easier, and I also have a common denominator that's already half there. These both already have an x minus 6, so I don't need to multiply either one by that. The first fraction has an x plus 6. That means I have to multiply the second fraction by x plus 6. The second fraction also has an x out front. That means I need to multiply it by x out front. So I now have x times 1, which is just x, divided by x plus 6, x minus 6, plus 1 times x plus 6, divided by x plus 6, x minus 6. And we have a common denominator. When you have a common denominator, you multiply the top in. It's just a 1 multiplying in, so nothing's going to change, right? It's just going to become 1x and 6. And then you're going to add the tops. So I'm going to have x plus 6 divided by x plus 6, x minus 6. If I collect those like terms, that will be 2x plus 6 divided by x plus 6, x minus 6. And you're not done a question until you have one fraction, which we have. You can't factor. Oh, I actually can factor this, right? The 2 can come out to become x plus 3. Now I'm done my factoring. My last check is, can I cancel any of my binomials out with binomials? Can I cancel my monomials out with monomials? The answer is no. That is my final answer. It's 2 times x plus 3 divided by x plus 6, x minus 6. Awesome. Here's 2 questions for you to try. They're very similar to the ones above. I want you to pause the video and attempt them. And then I'm actually going to do this question without talking. So that when you unpause, the answer will just be there. And then you can see it. So go ahead, pause the video, and then try your best. All right. Poof, magic. All of a sudden, the math is all done on your screen. I just do it that quick. It's pretty impressive. I've done both questions for you. Hopefully you got the same answers as me. I'll talk through them. So this first question, I stated my NPVs, and I also put brackets around everything, so I reminded myself they're packages. You'll notice I got a common denominator by multiplying by p plus 1 and p minus 2 on the right side. It gave me this step after I had my common denominator. I then had to multiply my tops, right? You see the red and the blue. I tried to color code it. So I foiled or distributed. So p times 1, p times -1, 1 times 1. Gave me all this. So all those terms, and then it became one fraction. So it was only p plus 1, p minus 2 on the bottom. I then combined all my like terms. So on the top, my p squares became 2p squared. All those p's worked down to plus 1p, and then minus 7 divided by p plus 1, p minus 2. I knew I was done because I couldn't factor. You'll notice over here I tried. I drew a little diamond and I attempted, but I couldn't find any numbers. And then I also knew I was done because I could not cancel any packages out. Awesome. This one. First thing I did was I factored. When I factored, I did a difference of squares on that right-hand side, right? So I square rooted 3 and e squared, which gave me 3 minus e, 3 plus e. I then did my little trick so that I could make this 3 minus e turn into e minus 3 by factoring out a -1 and then floating that -1 into the middle to make it an addition problem. Once I did my little trick, these two things were now the same. So I had an e minus 3 on both already. That means only the first one needed to be multiplied. It needed to be multiplied by 3 plus e. You could have written it as e plus 3. It's the same thing. I then had my 2 common denominators, so I multiplied the top to be able to write it as one fraction. I collected my like terms, and boom, I'm done. You'll notice that halfway through that question, I actually did change it from 3 plus e to e plus 3. I think it just looks better that way. It doesn't make a difference if you reorder addition. Awesome. There's one more little picture of all the work being right. So if you want to pause and make sure your answer is right. Cool. Let's try another one. So we got a question here. It's a little bit bigger now. We got some trinomials on the bottom. The steps don't change, right? So our goal is to write this as one fraction and then simplify it. The first step is always factor. So this one will factor to be 5 x squared minus 25, use square root to be x plus 5, x minus 5. Plus 4 divided by, you do diamond method on that, you'll get x plus 5, x plus 5. First step is factor complete. Second step, state your non-permissible values. X cannot equal positive or negative 5. Now we can start to simplify. To simplify means to write as one fraction. If I want to write that as one fraction, I need a common denominator. That means this x plus 5 has to be in the other fraction as well, which it is. This x minus 5 needs to be in the other fraction, which it's not, so I multiply by x minus 5. What I do to the bottom, I do to the top. Then there's another x plus 5 in the second fraction. So if the second fraction has 2x plus 5s, the first fraction needs 2x plus 5s. So you multiply it by another x plus 5, top and bottom. That gives me 5 times x plus 5 divided by x plus 5, x plus 5, x minus 5. The second fraction is now 4 times x minus 5 divided by x plus 5, x plus 5, x minus 5. We now have a common denominator. Now that you have a common denominator, you can multiply the tops into their brackets so that you can then add and subtract like terms. So this becomes 5x plus 25. The other one becomes plus 4x minus 20. And it's all over x plus 5, x plus 5, x minus 5. You'll notice there's some like terms you can collect, right? The x's combined to just be x. 25 minus 20 is plus 5. Divided by x plus 5, x plus 5, x minus 5. You know you're done the question. 9x, sorry. You know you're done the question when you have one fraction. We have one fraction. You can't factor. I can't factor that top, but I am going to put brackets around it so I remember it's a package. And you can't cancel any binomials out with other binomials. When you can't do those two things and you have one fraction, then your job is complete. That is your final answer. Awesome. We have one more here, and then two more. We're going to do this one together the next 2 we practice. So we look at this guy. First step, you want to factor. Always factor. So on the top, I have n minus 2. I'm going to leave it as n minus 2. In the denominator, I diamond method that to be x minus 3, x minus 2. My second fraction, n plus 4, is now in brackets. In the denominator, things that multiply to be 30 and add to be 11 would be n minus 5, n minus 6. Like that. The second step is non-permissible values. Things that cause me to divide by 0. N cannot equal 3, and also cannot equal 2, also cannot equal 5, also cannot equal 6. I got those from the denominators. Wonderful. Once you've done that, we can start to work with our simplifying. Now, there's something unique about this question that we haven't had to deal with yet. And that unique thing is that when you go to get your common denominator, we can actually save ourselves a lot of work by recognizing that one of our fractions can be simplified. So if I can reduce a fraction right off the bat, then you should, because that will save me from having to get this common denominator of n minus 2, right? I won't have to do that now. So I want to simplify that n minus 2 first. That means I now have n minus 3, which will go over here, but it does not need the n minus 2, which is nice. If I look over on the right side, there's an n minus 5 and an n minus 6. So I need both of these on this side. Like that. Now, if I was to rewrite this out, I have n minus 5, n minus 6, divided by n minus 5, n minus 6, n minus 3. Subtract n plus 4, n minus 3, divide by n minus 5, n minus 6, n minus 3. Like that. Now, what I don't want you to get confused with is we just went and got a common denominator. And we also learned that you can simplify fractions before you do things, like what we just did with that n minus 2. But then what people start to do is they start to go, oh, okay, well, look, n minus 5 and n minus 5 can cancel. Oh, and n minus 6 and n minus 6 can cancel. And people start simplifying things right now. If you were to simplify those, what you're doing is you're getting rid of your common denominator. That's why you can simplify again. And you need this common denominator. So you need to not simplify this step. Because you need to realize you're the reason why it looks like things can cancel out. Because you put those things in so you had a common denominator. You only cancel things out before your common denominator if you can. Cool. Simplifying this. If you want to write this as one fraction, you're going to have to multiply the tops. So this becomes n squared minus 6n minus 5n plus 30. And then on this side, you're going to have to multiply the top to give you n squared minus 3n plus 4n minus 12. However, this negative has to be dealt with. The way it's dealt is that when you multiply that right binomial, it's technically still in brackets because that negative needs to come into the brackets and change all the symbols. So make sure that you don't forget this is a subtraction question. Awesome. Now that I've multiplied my tops all nicely, I can add and subtract like terms. The n squares now cancel out, right? N squared minus n squared, because the symbol changes now. Cancel out. All my n's, I have negative 6n minus 5n plus 3n minus 4n. You put that in your calculator, and you will get negative 12n. I then have plus 30 plus 12 to be plus 42. Divided by n minus 5, n minus 6, n minus 3. Like that. You're done the question when you have one fraction. We have one fraction. You can't factor. Ooh, I can factor this. So if I look at my top, I could take out a 6, leaving me with negative 2n plus 7. All right, let's try again. So you know you're done the question when You can't factor. Now I can't factor, and you can't cancel out any binomials. All my binomials are different, so that is my final answer. Zoom out so you get a big picture of everything again. That's a pretty tough question when it's a subtraction like that. Lots of little intricacies. All right. This question and this question are just going to be practice questions, so you can go ahead, pause the video, and try them. I'm going to skip the next two questions. Again, we're just going to try to reduce the size of these videos for you guys. They're bonus if you want to try them. Pause the video, do this question, come back, and I'll have the answer. All right. Hopefully you pause the video. Here's the work and the answers. So you'll see the first step I factored. Then I started to get a common denominator. I had to multiply the first one by x plus 7, the second one by x minus 7. On my tops, I multiplied in the 7. I multiplied in the 3. That allowed me to add and subtract the top. So 7x plus 3x is 10x. 49 minus 21 is 28. I could factor, so I factored a 2 out of the top, and it gave me my final answer. 2 times 5x plus 14 divided by x plus 7, x plus 7, x minus 7. Some people might write x plus 7 squared. That's fine. Same thing. Cool. Try this one. So pause video, try this one, and come back. You'll see the answer. All right. There's your work and answer. So the first thing I did was factor. Then I say my NPVs at the top of the screen. This question is unique because I could simplify these n minus 3s. That saves me on my common denominator, right? So I multiplied, or I canceled out those n minus 3s, so I didn't have to multiply by n minus 3. My common denominator is n plus 5, n minus 4, n plus 6. I multiplied on the top in the red and the blue. Notice that I highlighted the subtraction in green. That negative sign has to go to all of these, making it negative n squared, negative 6n, plus 2n, plus 12. Right? And then you can combine all your like terms. But that negative has to come in to the brackets. Awesome. Once you did that, you should have added all the things together. The n squares cancel out. I have negative 3n's and then negative 8. Common denominator doesn't change. I know I'm done because there's one fraction. After the one fraction, I then have no factoring that can be done, and then I have no binomials that can cancel with other binomials. Wonderful. The next two questions are just extra questions. You don't need to worry about doing them. Practice your adding and subtracting. And don't forget to join us for tomorrow's exciting episode. It is a thriller, people. So you just wait. Take care of yourselves. Talk to you soon.